Good evening, ladies and gentlemen. Welcome to my studio, or a room that sounds fairly echoey because I'm far away from the microphone at the moment. But it is a space where I can create things and share them, and they can be messy over there. I can have a desk here, and it's whatever. So welcome. I haven't done a blog video in a while. I'll have to do that here soon. I have both the YouTube live chat and the IRC up. So if you have any questions, comments, concerns, or suggestions, you can hit those up. It is an Ask Me Anything sort of evening. So while I sit here and build this Z80 Kit Computer, which I will show you here in a moment, you are welcome to chime in and say hello, or if you have any electronics questions or computer or car questions, I'll be fielding those as well. So sit back and enjoy. Oh, hey, Bill. Good to see you. Well, you can see me, but yeah, how's it going? So we'll get right into it here. So this is, I hope this works. I have this, you can't really see this, but I have a webcam taped to a tripod. Okay, so what is the purpose of the Z80? Well, the Z80 processor is an 8-bit processor that was used in a lot of computers in the 70s and 80s. It was a quite popular alternative to, well, it wasn't really an alternative necessarily, but it was one of the pioneering processors that personal computers kind of mainstream. Most people program them using like the basic programming language and stuff like that. It's actually a lot easier to learn about electronics and computers by kind of working with microcontrollers, because something like this is nowadays all consolidated into a single chip. But I figured I'd have a little fun with this because I'm actually going to build a retro clock of my own. I have a weird announcement to make too. I created a Facebook because a lot of people are like, hey, you know, find me on Facebook or find this on Facebook, and 1/4 of Earth uses it, right? So I guess I had to at least create one to stay in touch with all of my friends. So with that being said, I've posted a couple of things there, and one of the things that I've been working on is I've been helping my buddy Trip build a clock. Using CRTs out of old pocket televisions, and one CRT displays one digit on the clock. So there's 6 of them, and all the supporting circuitry and everything. And so I thought it'd be neat when I build my own clock of that, to control it with something kind of period correct and special in that way. So I think I'm going to use this for that, using GPS to get like the time and date. And then this will drive the displays. So anyway, I picked up this computer. I've stumbled across this gentleman's videos. I'll put up a link to it when I actually have a video of this computer in a little bit more detail. But he was having a lot of fun with it, creating his own circuits and doing some stuff. And I went and looked up the project, and this RC2014 Kit Computer was designed and built by another hobbyist who decided to offer them as a kit. And I was like, this is really neat, because I could build my own circuits and interface it with this and learn about writing drivers. There's even a Unix environment that will run on this. So I thought it'd be kind of a neat way to dabble in the world of Z80 processors. One thing that I do like about the Z80 CPU specifically over anything else is that clock rate. So when you're trying to teach yourself assembly language programming, and you want to single step through a program, now like the PIC microcontroller, for example, the debugging tools, if you have like the Picket and everything, allow you to do this. It's wonderful. But when it comes to this processor in particular, there's no minimum clock, so you can completely stop the processor and view the contents of the registers and see where exactly you're at in the execution of your program, and look at the state of the registers and look at the contents of the RAM to gain a better understanding of how your program works, or if you're troubleshooting something in particular. So it's a neat tool in that regard. Maybe not the best way to teach yourself about electronics, but certainly a fun one, we'll say. So this is the RC2014 Kit Computer. And I've actually ordered some extras with it. Today we're going to do the basic assembly of this. And while I do that, I'm going to watch the YouTube live chat, and I'm going to watch the IRC. I am on the Freenode IRC server. The room name is Doogie Labs. So if you want to jump in there, you can visit with everybody else at the same time. And so let's go over what I received here. Record on this too. All right, we're good to go. These are proto boards. We'll set those aside for now. We'll just kind of take everything out of the box. Very simple. That's what I like about this. It's an easy way to show others how a computer works, because like I said earlier, all of the stuff that's on here is consolidated into a single chip now. So in some ways, that makes it a little more difficult to understand how these things are interacting with each other electrically, and this allows you to do that. So this is the back plane of our RC2014 Kit Computer. There's the back there. And this is a motherboard. So 8 slots. The Z80 is an 8-bit CPU. So you have 8 slots here, and there's more than 8 address lines, so you can, address a little bit more RAM and talk to a little bit more than just 8 bits worth of things on the bus. So there's that. It's completely passive in nature, and by passive I mean that there's no chips on here that are required for the things that are plugged into here to talk to each other. All of the circuitry that facilitates the communication between the boards plugged into here happens on each board individually. So in our kit, we have, and of course this camera is not going to do macro. We have our Zilog Z80 CPU. We have some 7400 series logic, and that's also worth noting is that all of the quote-unquote glue logic is 7400 series logic, so it uses TTL logic levels. So that's I don't want to say it makes it easier to troubleshoot or anything like that, but it is certainly more resilient to things like interference or static electricity. Don't get me wrong, static electricity can still kill these components with enough effort, but they're just a little more resilient. And then on here we have 32K of SRAM, and then we have a PROM. Now instead of like a windowed EEPROM that you would normally have, this is a flash ROM. So I can plop this into my programmer and change the code, and I don't have to put it in a UV eraser and wait 15 minutes every time I want to do that. And some of the options I've ordered kind of change around how that works. And you can add things like a floppy disk controller. There's a compact flash adapter that you can put in here. So you can develop anything you want for this. It's just a little slower than it would be on, although simplified. So in the box, Hugh, hey Doogie, I tuned in late. Why build this kit? I just kind of covered that, definitely. But a brief explanation. The reason why I'm building this kit is, for me, it's kind of a toy, a little bit educational, because I always pick projects that kind of are a little bit outside the comfortability zone of in what I do, and that therein allows me to learn new things. But this hopefully will be the basis of a project clock that I will be building for myself, which I will cover in a lot more substantial detail once I have procured more of the parts. So in with the RC2014 Kit Computer, we have a fast and loose assembly guide. It's very, very fast and loose. And then it covers like what some of the headers are. It talks about the clock board, and then here's the RAM board over here, and a serial I/O board. Now what we're going to do first is assemble the motherboard, because that's going to be one of the easier things. Now, there's many different ways that you can go about assembling a circuit card. Usually what I do is I work from biggest to smallest. So I'll do like chips or chip sockets, connectors, headers, jumpers, and then I'll move into the smaller stuff like resistors and capacitors and other passive components. And that's not always the best rule of thumb. Sometimes you'll have components that end up really close to chips or chip sockets or headers. And at that point, it would be more advantageous to solder in the smaller component first and then move on to the larger ones. So I guess it's your personal preference. Just evaluate what you have to assemble in front of you and pick the best route. So what I'm doing now is I'm installing all of the sockets into the backplane. And sockets are kind of tricky because you gotta, at least generally speaking, you want them straight. So I'm hoping that I can get these on here straight, and I have a trick for that I'm going to try. So what I've done is I've installed all 8. Now the normal kit, if you order the full Monty, and that's, by the way, the website for this computer is rc2014.co.uk, in case you wanted to go check that out. So anyway, the full Monty kit that I ordered normally comes with 5 of these slots for the motherboard. Because I ordered the prototyping cards, they included the extra 3, so I have all 8. And now what I'm going to do is I'm going to take a piece of paper and I'm going to set it on top of this. I'm going to flip it upside down so none of those fall out. And then I'm going to slide the piece of paper out. And now we are working upside down. I'm going to look and see how square everything is. And the answer is fairly. So, take a drink of water. Yeah. All right. And I have my soldering iron set at about 650 degrees Fahrenheit. Your mileage may vary. Got some solder. And my iron. I got my finer tip on here today. So the best way to do this is to, and this is true for any multi-pin device, whether that be a pin header or a chip or maybe not a transistor, that's only 3 pins, but you know, anything with 4 or more pins on it. So you start by soldering a corner. And then you solder the opposite corner. If it's a 4-pin device, you could probably get away with just 1 corner. Get yourself straight and set up. So I'm going to go through and solder each one of these. And feel free to bounce questions off me, guys. And this is an Ask Me Anything as well. So if it does not pertain to electronics, that is fine. It can be cars, computers, electronics, personal questions. Well, it's an anything. I guess you could ask me political questions as well. I'm sure others probably wouldn't appreciate that so much, so I will do my best to avoid those. But generally speaking, you can ask me anything. All right, so I'm soldering the very edges of each one of these 8 connectors, and I'm kind of avoiding the one that's slightly crooked. Actually, it straightened itself out. So let's go ahead and do that. That paper trick worked pretty good. I recommend that to anybody who's trying to put one of these together. All right, solder the tops and the bottoms. I need to set up a little solder extraction fan here on my desk. Breathing lead is not good for you guys. Okay, so I've got all 8, and now I'm going to check and see how square they are. And that came out pretty good. That came out pretty good. Looks like I only have a couple to fix here, so I'll give it a push with my thumb. If I can just get it to sit against the board, because they're square on the bottom side, they'll correct themselves if you push evenly and against the board. Okay. I like my stuff looking neat, so I think I'm going to go through and just make sure the rest of these are fully seated before I permanently lock them all in place. I guess in the world of soldering, nothing's permanent. With enough heat and force. I guess that's true with anything, right? Aaron, what is my job? My official job title is Chief Technology Officer for a local company that manages a half dozen veterinarian offices between North and South Carolina. I manage their technology infrastructure, and I also do day-to-day operations, like I'm an assistant to the operations manager, and I also handle like repairing the medical equipment, making sure that the websites work correctly and stuff like that. So it's a fairly broad range of skills that my job requires. It's kind of nice. I'm not doing the same thing every day. And then whenever we're caught up on work, and sometimes not caught up on work, I build cars for my boss. Lead-free solder? No, this is not lead-free solder. I am not a fan of lead-free solder, just because, and mind you, I've never actually used lead-free solder, but I avoid it for 2 reasons. One is leaded solder flows better, lower temperatures. I don't like putting massive amounts of heat into things, so I try to avoid that. Okay, so I have went through and corrected all of my headers, and they're pretty straight now. This one's kind of, we're going to fix this one again. And down there at the far end. This one's weird. I think it got bent in the middle or something during shipping. It just kind of looks funny. Okay. Cool. So now that those are all straight, we're just going to go through and solder these together. One pin at a time. So there's 8 of these connectors. I don't know how many pins there are in a row here. 40? That equates to a lot of soldering. So what I'm doing here is you tin the tip, and by tinning the tip, for those of you who aren't soldering folks, you the solder to the end of the tip. You want to do this after you clean. So you clean, you get the crud off, apply a little bit of solder, and now that the tip is wet with molten solder, that allows for a more reliable heat transfer, and you touch the tip to your work, and then I come in at the other side with the solder. Sometimes I'll drape the solder between the tip and the thing that I'm soldering to, and that yields pretty good results. I think typically in practice, you're not supposed to do that, but I do what works good for me and provides a good end result. I have soldered a lot of things in my life, so I think I'm fairly proficient at it now, albeit I have not done much in the way of surface mount. Have I seen Anonymice lately? Not since yesterday. For those of you who are just tuning in, I am answering your questions live. You can drop your questions in the live chat here on this YouTube page, or you can join us in our IRC channel. That is on Freenode. You can actually point your web browser to webchat.freenode.net. Enter hashtag Doogie Labs for the room name, whatever nickname you want as your desired nickname. And you can chat with me and a bunch of other people in there. And if you're getting into electronics, or you have electronics questions, or you have car questions, even if I'm at work or not available, there is a room full of people who are more than happy to offer their advice. And there is a lot of smart people in there, and there's a lot of people in there that are a lot smarter than I am. So it's a fun place to hang out. Monkey, we'll get you doing more surface mount one of these days. I really do want to get into surface mount. After eyeballing the hot air station that I was working with last night at Hackerspace Charlotte, when I was helping Trip build his clock, I must say, I know it's a Chinese hot air station, and that's terrible in every way, but it's better than nothing. And I would love to get that, just to try and get in there. I need to clean my tip. I'm starting to get poor heat transfer. And when you tin, don't tin your tip to where there's a blob on the end. You can see it just melt over the surface there. When you know that you have a good, or then you know that you're tinned good. The roll of solder I'm using is probably 40 years old. I bet Monkey knows this. Does solder have an expiration date? Does it go bad after a certain period of time? Agreed. Lead-free is the way to go. ROHS compliant stuff is crap. 6236-2 is the best solder I has ever used. Plus, way tastier. I don't know how many times I've put leaded solder in my mouth in my lifetime. Is lead poisoning accumulative? Does anyone know that? I'd be curious to know. I got a little twist in my wire here. Okay. So I'm just going to flip this around and solder the other end first. I'm going to do the ends and work my way in. I hope y'all are finding this fairly entertaining. I'm not exactly running a production show here, major production show. I hope to be reunited with my better cameras, computer, and desk/lighting setup real soon. And then we'll be making a lot more awesome videos. Maybe I'll send you a couple of these boards when they turn up. Surface what? You don't need anything special. Chinese stations work. They just have the occasional problem of catching fire. It can wick moisture up with the flux and start to spit and perform badly, but it won't get far. Yes, lead poisoning is somewhat accumulative. Chronic poisoning is a thing. Aaron asks, what are your favorite car makes and brands? Or makes or brands? That's a loaded question because those who follow me know I have nothing but VWs. But with that being said, I'm not entirely impressed by their latest products. So I don't have, say, a favorite car manufacturer. As a matter of fact, I can basically appreciate something from every car manufacturer. Might be hard to find nice things to say about Chrysler, but nevertheless, there is something in there. So it just depends on your preference, because I haven't seen anybody consistently make good stuff for a long period of time. It seems that sooner or later, the what do you call that? The temptation for maximizing profit and the lust of the bottom line is what ultimately destroys products. And you know, with cars, it's kind of interesting because I haven't really seen a new car within the last 5 years, I would say, that's thoroughly impressed me. Except maybe the Tesla, I guess, because they're innovative. That would be the only, that would be the given, like, because they went kind of against the grain in a way and worked diligently to try and create a car, an electric car that people could obtain and practically use. But with that being said, I am a huge fan of the internal combustion engine, and there is nothing like the sights, the sounds, and the smells that it doesn't compare. When you have, I mean, there's just some beautifully amazing engines in the world, and you can hear, as a car person, I can literally hear the engineering that goes into some of these engines, and it's very special. And so how does that translate into why I'm not impressed by any new cars? Well, it's because they've lost their personality. I am a huge fan of electronics. I am a huge fan of technology. I'm sitting here assembling a circuit board for a kit computer because I love computers. But with that being said, I am not a fan of the computerization that has happened with cars. Yes, self-driving cars are important, and ultimately the computerization of cars has been to work towards that goal over a period of time. That is without a doubt the case. But when you remove the raw driving elements of things like steering feel, how a car feels when it's at its limits, if you're doing emergency maneuvers and stuff, you you get comfortable with the electronic aids, and it makes you a worse driver in some sense. And in others, it's okay, because there are people that, despite driving an analog car for 40 years, when an emergency situation arises, it is human instinct to just flat out mash the brake pedal, right? So I get that. ABS is immensely helpful in that sense, because while you got your foot mashed on the brake pedal and you're coming up on a car that you're about to rear end, and you look around and you're like, oh, I got a space, and then you try to steer out of it. If you don't have ABS and you forget that your foot's to the floor on the brake pedal and your wheels are locked, you're not going to be able to steer out of it. And a lot of people don't think to release the brake pedal so they can steer out of it, or modulate the brake pedal in a fashion to begin with where you're braking and remaking traction and kind of exercising that point at which you have the maximum stopping power. And honestly, I really think that if we had a more serious approach to driver education in this country, that those problems would be resolved. My case in point for that would be, if you look at Finland, there's a very good reason why a lot of amazing rally drivers come from Finland. And it's because during their day-to-day driving, they encounter a wide variety of terrain and conditions, and the training of drivers in that country, at least the thoroughness, far exceeds the written and practical cheeseball exam that we take in America. I mean, if you could somehow pass a 10-year-old for being 16, you could take them into motor vehicle and they could pass the written and practical driving test. I bet you. Like, that's how low the bar is, at least in my opinion. Maybe you guys feel differently about that, but that is one of the many reasons why I, as a person who loves and embraces technology, am against the computerization of cars. And they've lost their personality as a result of that. The differences in characteristics of vehicles before the end of the analog car era was dictated by far more than just looks. For example, handling characteristics. I like light, nimble cars that snap around corners really fast. And with a computerized car, the go-kart-ish feeling, yeah, it's still there to some extent. Don't get me wrong. It's not like it's completely removed, but it's just ruined. I don't feel like I have the same amount of control as I do, in a full analog car. That combined with the feeling, like just having feeling in the accelerator pedal, like I can tell how the engine's behaving. Because there is a physical cable that's linking the vibrations of the engine to my foot. And you get different vibrations than you would if, say, you only had the vibrations that were transmitted through the floor. Right? Those vibrations are dampened by engine mounts. So you might miss something. Let's see. Tesla Model S. I'm not going to say any particular Tesla model. Just the make as a whole. Okay, I will give you this. One car that has actually impressed me in the last little while was the Ford GT. I don't know about the newest one, but like the 2006 Ford GT, that is like a real effort made on Ford's behalf. And I understand it's like a $150,000 car. Well, it's a lot more than that now, but and that's kind of not fair too, because it's supposed to be quality. You're paying $150,000 for it, but seeing Ford put in the effort impressed me. I really liked the car. I liked how it drove. I liked the handling characteristics. I liked the sounds. I liked the linear feel of power delivery. I liked the width of the car. I liked looking out the back window and seeing a giant supercharger sitting behind me. Like, they got it right. And one of the things that has also ruined personality in new vehicles is everything is market research, tightly controlled, hours of board meetings. Oh, do we want gray suede seats, or do we want 10% darker gray suede seats? We should put the heater knobs like this because that's what people want. An engineer is no longer given free reign over the entire thing. If you look at historically fantastic cars like the Nissan 300ZX, for example, the Z32, the twin turbo, that car was made a fantastic car, not necessarily because of its heritage. It did have a little bit of heritage, I'll give you that. But it was made a fantastic car because it was an engineer's wet dream. Somebody went to an engineer and said, hey, we need a car, and we need a good car. We need a sports car that makes people want to drive, that inspires people. You know, go nuts. Here's a clean slate. Let us know what you come up with. And at that point, an engineer isn't restricted by market research and all this consumerist bullshit. And let's face it, in the early 90s, you had a lot less safety constraints as well. But an engineer was free to take that and run with it. And this happens all the time. Engineers have their, side projects, and they design these cars and stuff. And surely these cars are presented to, these board members or management at these automotive companies, and some of them are built. But it's been a really long time since somebody decided, hey, let's just be hands off. Let's take it. Let's give an engineer a project. Let him run completely wild with it and see what he comes up with. And in my opinion, that is how we've gotten some of the most amazing vehicles we've ever had, is for that singular reason. Okay, next question. Do you like chocolate? I do like chocolate. I perhaps like chocolate too much. Cars should be halfway, have the option to manually drive a computerized car. Well, that's a good point. And I really think that at least for the next 50 to 100 years, we will always have that option. I think it'll be a legally mandated requirement that a car somehow has the facilities incorporated within it to allow the occupant to take full manual control to drive the vehicle wherever they want. But with that being said, I feel that another approach to this is that the government or nation state or municipality or police will have some control or authority over this as well, because I know how much they are chomping at the bit to be able to remotely access and stop a vehicle without having to use force. And while I agree to some extent that that is useful. I wouldn't want that on my car. I don't want anybody else for any reason to suddenly decide that I am not going to drive in my car anymore because they have a laptop and incorporate that kind of technology into a vehicle anyway. There's the inherent security issues that come along with that, because of course that power is going to be abused, and arguably it already has in a couple of instances. Funny enough, the CIA in the recent document dump, I think that was in there. There was revelations about how the CIA was experimenting with being able to infiltrate vehicle computer systems to, take advantage of the features of the vehicle to take out a target or stop that target for apprehension and stuff like that. And don't kid yourself, that stuff is entirely possible. As a matter of fact, that was feasible 10 years ago. We're there. So be careful. For the 99.9% of us, it really doesn't matter. And that kind of goes back to the whole everybody's on Facebook and they don't care that they're being monitored, traced, and tracked and used as market research data every moment of the day. And I didn't use Facebook for years and years and years because it's the principle of the thing. It's the principle of the thing. But hats off to Zuckerberg and everybody else who plays that game, because they know that if you build a social platform that everybody in the world can use to freely communicate with everybody else in the world, there's no better way to have everybody in the world by the balls enough that you could, leverage everybody for market research and obtaining useful information. Okay, next question. Computerization of cars has come with a notable lack of security. Yes, I agree. And that will only get worse, at least for a period of time, before I feel like it's going to get any better. And it's kind of a competition, right? Because as cars get more secure, computers get more advanced, and with leaps in processing technology and stuff that enables us to crack encryption faster and hashes faster, which allow us to gain access to things faster. So it is a race. Actually, we'll go back like this. I have 6 of the 8 slots soldered in so far, so we're just trucking right along here, assembling our RC2014 Kit Computer. For those of you who have just joined us, hello and welcome to Doogie Labs Live. This is the first time I've streamed live in a long time. I'm doing an Ask Me Anything tonight. I am watching both the YouTube live stream chat and the IRC. You can join us in the IRC live. That you can point your web browser to webchat.freenode.net. Enter hashtag Doogie Labs in the room name and your desired nickname for your desired nickname. And you can join in. You can chat with a bunch of other people at the same time. So, next question. Message retracted. Aaron, what is your opinion on Hondas? Is VTEC really that great, or is it overrated? Well, VTEC is interesting, and I think at least the VTEC technology itself, not necessarily the attempts at implementations of that from other auto manufacturers, but if you look at the VTEC technology itself, I think that is very neat. And for those of you who don't know what Honda VTEC is, it is basically well, okay, so you have a camshaft in a car, and the camshaft is a a shaft with a bunch of eccentrics on it that turn, and at a certain point they push down on a valve which opens it and then closes it. And this all has to happen at a certain time. Now, the distance at which that valve opens and closes, and the duration that the valve is open for, and everything else is dictated by the profiles of these eccentrics on the shaft, on the camshaft. And when you look at a race engine, for example, they have a camshaft that has a really aggressive profile to it. So when the valve, between the time the valve starts to open and the valve is fully open, that is a very aggressive moment in time. Like the valve moves very quickly from fully closed to fully open. And then on a race camshaft, typically that valve is opened a little bit further. And to achieve opening the valve that far in that short amount of time, it does require a more aggressive profile, the stock camshaft, right? So what VTEC does is it allows you to have the best of both worlds. Oh, I guess I didn't touch on this. When you have a race camshaft, it is extremely beneficial, because it increases engine power. But what's the cost? There's always a give and take when there's performance modifications happening with engines. Well, that cost is drivability. So when you have a large lumpy camshaft in your engine, the engine idles a little bit rougher. Sometimes power delivery is almost non-existent down low. And when that happens, the car just doesn't drive in traffic as well as it should. And so Honda decided to try and combine the best of both worlds by implementing VTEC. Now, VTEC combines the street camshaft with the race camshaft, and it does this by shifting the camshaft over slightly physically using oil pressure to a lumpier set of lobes that are more aggressive. And so and there's some other things that play into this as well. For example, to get more torque in an engine, you want higher air velocity moving through the ports. And sometimes if you, let's say if you port your cylinder head really big and your valves are opening really far, at a lower engine RPM, you're not going to have a lot of pressure, a lot of velocity. And so by limiting like the diameter of the intake ports, or by limiting the distance at which a valve opens, you can increase the intake air velocity and thereby increase torque. And so Honda chose a specific RPM, 5,200 RPM, I think, 51 or 52, where it switches to the race cam profile. So they've determined that, okay, at this point in the RPM range, it is the air going into the engine is moving fast enough, and we're far enough outside the normal driving range that we can switch to the aggressive cam profile and make a crap load more top-end power. Now, if you were to take just the race cam portion of that VTEC camshaft and make a non-VTEC camshaft with just that profile, it drives like crap, right? And so that's what VTEC is, and it's a good technology. For those of you just joining us, this is an Ask Me Anything. I'm watching the YouTube live chat. You can plop your questions in there. You can also join us in the IRC channel, webchat.freenode.net, #DoogieLabs for the chat room name. Okay, so, and this is cars, computers, electronics, personal questions, open season, guys. And we're putting together a Z80 Kit Computer while I do all of this. And I guess I never gave my opinion on Hondas in general. I just explained the whole VTEC thing. And my answer to that is VTEC is not overrated. It is actually a fantastic technology that many people have reaped the benefits of in aftermarket applications. Honda in of itself, as a company and the cars that they make, I have not been in any new Hondas, but I would say as recently as 2012, vehicles like the Honda Accord, even the non-V6 trim level, felt like they had some substance to them. And that's important because we can't get a car with personality nowadays. And most of the time, you can't even get one with substance. And I must say that, at least in that regard, Honda has made some effort, certainly more than Volkswagen has, to maintain some substance in their cars. Next question. Oh, they're arguing about solder. Okay. 300ZX is kind of cool. What is EFM8? Okay, so that's all the questions for now. I'm almost done with these slots. This part always takes long. 40 pins per thing, and there's 8 slots here. Boy, this has got to be riveting. We're watching a guy solder what I'm building, just to cover some details. This is a Z80 Kit Computer. The Z80 is a microprocessor that was used in the 70s and 80s. It was maybe not the first, but certainly one of the most notable processors used in that era. It was a major contributor into making personal computers personal, instead of monolithic cabinets that occupied entire rooms. So I'm building this kit computer. I saw this kit. It was designed and offered by another hobbyist. You can go to RC2014.co.uk to check it out and get one for yourself if you like. But I decided this would be kind of a neat toy, a little bit of a learning experience, and I get to support somebody else much like myself who works to design, implement, / offer kits and toys and things for other hobbyists with similar interests to enjoy. Personally, I'm engaged in some unriveting. Oh my goodness. You need an intern to do that part. Yeah. Well, yes and no. An intern could certainly do this. Whether or not it's done correctly might be another question. So yes and no. All right. Finally, we're moving on to the next build, and that is some capacitors. Turn the magnifying glass. It's my poorly lit room. Welcome to my new studio, by the way. 421. I think these are the same. Oh, 104. These. Am I that blind? How did I get 421 out of that? That's crazy. They are 104 though. I am not under the influence of any mind-altering substances whatsoever. I just have bad eyesight this evening. All right, so we're going to throw these capacitors in here. Now these, there's one of these at the power rails for each bus slot. I think so. Yep. You can't really see this, but there's ground and 5 volts, and at each slot there is a capacitor. And they're called decoupling capacitors because they work to help eliminate the power supply. Because if you don't have a solid 5 volts DC and it's kind of waving around all over the place, that's going to create some undesired results with your signals. It's worth noting that I thought I had, oh, okay, they're over there. It's worth noting when you put through-hole parts in a board, I put them straight through like this. Or I'll have to do that over here so I can see. Got to draw some hair around it to find the hole. All right. After you poke it through, bend the leads out a little bit. There you go. So see that? Looks like some rabbit ears there. And that holds the parts in place. So now I can go through and put the rest of these in, and then I can go back and just solder them in straight away. So throw another one in. And another one. We're going to do all 8 of these at the same time. Another one. Curtis Smith, what's up? We're just building a computer from components and having an Ask Me Anything. So welcome, and pull up a chair and enjoy some riveting soldering skills. I'm sure this is fantastically entertaining. Maybe I'll move on to like the CPU board or something after this. We'll do something a little different. Although the CPU board doesn't have much to it, I'll say. Now, the kit computer doesn't come with everything. They have a 7805 regulator because the whole computer works on 5 volts. They have a spot here for a 7805 regulator and a couple of capacitors. And the 7805 is not included. And this is because the 7805 regulator in of itself is horribly inefficient. And there are alternatives like USB, for example. So if you're going to be powering this from USB, which you very likely might be, you don't need the 7805 regulator, and most people will probably do that, and therefore it was omitted. What am I going to do? I don't know. I might put the 7805 regulator in it. I have a few of them, so I just might do that. And thank you, Nathan. Was it Guy? Might have been Guy. Sent me some 7805 regulators, and I have been using them. So thank you. So now all of our capacitors are in place, at least our decoupling capacitors for each slot. So I'm going to go ahead and solder those in. So if anyone else has any questions, this is an Ask Me Anything, and you can ask me computer, electronics, car questions, personal questions, questions about your girlfriend or whatever. I am open to whatever you want to throw at me tonight while we hang out and assemble this Z80 Kit Computer. And for those of you who are just joining us live, you can feed your questions into the YouTube live chat right there. I have that open here on my computer, as well as our IRC channel, which is IRC webchat.irc. Oh my God, really? webchat.freenode.net. And the room name is #DoogieLabs. And your desired nickname is whatever nickname you desire. Yes. All right. My PC freezes when it goes into sleep mode. How do I fix it? Okay, well, is this a laptop or a desktop? And what operating system? What operating system? There's a lot of potential reasons why something might freeze going into sleep mode, so let's get a little bit more background information. All right, so we have all of our capacitors soldered in, so you can see our 8 bus slots. You can see our 8 capacitors. And now we got to cut the leads off the back. To do that, got to access the tool bag of tools. Tootly tools, tootly tools, tootly tools. All right. These are side cutters for those of you who don't know or haven't seen these before. It looks like a pair of dikes, but they have this flat edge against them, and they angle up slightly like this. So when you place them flat on a board, they're not invading the space of other parts. And this allows you to cut the leads off without struggling too much. Although mine appear to be magnetized, which is making it a struggle. Okay. It is a bad idea to cut screws, nails, heavy copper wire, or anything else like that with a pair of side cutters. They are sensitive electronics pliers. Or at least, side cutters are dikes. Those are flush cutters. It seems I have just been corrected. And given that it's a monkey, I'm going to take his word over my own. Yeah, and if I'm making any mistakes on any of my videos or anything else, by all means, correct me. I am open to reinterpretation of whatever it is I'm screwing up on that particular day. Let's see. My gaming desktop, Windows 10 Pro. What motherboard and processor are you using? Is Sudos in the chat? That might be a good Sudos question. I don't know if he's on the flush cutters. Monkey. Do they mean diags as in diagonal cutters? Or carpet licking lesbians? Oh man, you guys are hilarious. All right, so we've got all our leads cut off. Man, I need to demagnetize those. That sucks. All right, so here is a closer view of our RC2014 Kit Computer. We're making some progress so far. We're, man, an hour? It's taken an hour to do that? I need to start doing surface mount stuff. All right. What do we want to do next? I haven't actually read the assembly guide. I'm just going with the obvious first. The assembly guide mostly covers everything else because the motherboard's pretty easy. Reset button. Here we go. So we have a little tactile button. That goes here up in this corner. And this button has little, I guess, hooks on the ends of the leads. So when you push them through if you manage to do this without bending the leads. It kind of clips into place, and then you can solder it. Dun, 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 dun. Oh, goodness. All right, let's try inserting the pain in the ass side first. All right. So we have our tactile switch in there, and that's the reset button. And I didn't have to bend the leads or anything. They just barely protrude out of the back of the motherboard here, but because they have those clips in there, look at that. It stays in place. i7 6700K, Asus Tough Mark II, RAM is good, tested it on another board. So what happens when you try to wake your computer up from a sleep state? Does it blue screen? Does it freeze after a certain amount of time? Is it frozen immediately? So I'm curious. I wonder, it might, let's see if it freezes immediately. That'll be a good question. We're doing some live PC troubleshooting as well. So if any of you have advice to offer and be helpful in that situation, cool. Because that's what we do here on the Doogie Labs channel. We help each other out. Okay, we have our reset button. Satisfying. Now we have a power LED. Bam. And there's a little K on one side of the LED hull. I assume that means cathode. Hey, do you British people spell cathode with a K? Maybe. Oh, pro tip. It's a pro tip. LED cathode is marked K. Is short lead. Now, how I always determine the polarity of an LED is not by the length of the leads, because often I recycle LEDs and the leads are cut at the same length. And this is, you are not going to see this, but on one, you'll have to take my word for it. On one side of the LED, it is like ground flat. There's like a little skirt on the bottom. You can drill a hole and push the LED through, and there's a lip that acts as like a backstop so it doesn't push all the way through. And that lip is ground flat on one side, and that's the cathode. So that's how we know what polarity our LED is. So we'll go ahead and poke them on through. I'm going to do my same, bend the leads out. And this one I want to sit flat on the board perfectly because it's got a flange on the bottom that allows it to. So what I'm going to do is solder one side, and then I'm going to push with one hand and wet the solder with the other, and just get that LED perfectly flat on the board there. And one thing to remember too when you're soldering LEDs is use the lowest temperature possible and the shortest duration of time possible, because heat seems to destroy LEDs relatively quickly. And for those of you playing along at home, I have my Weller WESD, as in Delta, 5.1, set at 650 degrees Fahrenheit, not Celsius. That'd be a bit toasty. Okay. Let's see. No, cathode is cathode. K is a common shorthand in electronics. Ah, I learned something new. Because C would be common. Be warned, some LEDs are backwards relative to the flat or the lead length or both, and some don't have the flat spot at all. Whew. Okay. let's see. Interesting. I was just watching a video. This guy decapped an IC and watched the active IC under an electron microscope. Ah, you must be talking about Ben Krasnow with the Applied Science YouTube channel. Really interesting guy. I love his work. You know, I might be able to lower the camera down a little bit and get a better angle on this. I don't know. We'll try it. There we go. We'll see if that works any better or worse for you folks. And I appreciate feedback if the audio sounds weird or the video quality is weird or whatever. I appreciate your questions, comments, concerns, or suggestions. For those of you who are just joining us, quick recap. We are here live in the Doogie Labs studio, i.e., a spare bedroom with some cameras, some phone, and a laptop, and flag, right? It's so funny. But when I'm sitting here, and this camera is there, and it's pointed at my face, it actually works pretty good. I mean, isn't that what a studio is to accentuate the illusion, right? That we have order to chaos. All right, i7 4770K, gigabyte Z87 with 16 gigs of Patriot RAM. Okay, so if you don't have SSD in RAID, comes back to normal if I put it to sleep and wake it within 3 to 5 minutes. After that, the screen goes black and it is unresponsive. Look in your BIOS and see, and I'd have to actually have this in front of me to look at it, but look at your sleep state settings and see if there's like a deep sleep state. Because I think there's a couple levels of sleep states, and maybe it's like trying to go into that deeper sleep state and something's kind of lost in translation. So if you can just go into first level of sleep state, where perhaps most of the ancillary equipment in the computer is shut down and asleep, and essentially it's just keeping the RAM alive and refreshing the RAM. That might be the better way to go, which is what it should be doing anyway. I mean, the definition of a computer asleep is basically that. But I know that sometimes they have some weird things. So make sure that hibernation is disabled, and it sounds like it is, or you're not using hibernation, but double check and make sure that setting is turned off, and check your sleep states and see, what they are. Maybe you're using a legacy sleep state when you need to enable a newer one. And if Sudos is around, he would have better information on that. But that's the approach I would take. Other questions? Yes, Applied Science is the guy. Sound peaks. Other than that, everything's golden. Cool. Yes, keyboard. Okay. Cool. All right. So we have our LED. With that, we need our resistor. And according to this, it is a 330 ohm resistor. All right. What is a 330 ohm resistor? What are the color bands? I don't know. I have a thing. Oh man, I moved my desk, and the way that you move a desk, at least here, the way you move a desk Doogie style, is you take the entire contents of your desk and you scoop them into a box. And then you spend the next couple of weeks fishing the things out of the box that you need. And then you dump the box into the box of stuff that you scooped off your desk the last time. We kind of have this filing system, and then eventually it ends up in long-term storage. I'm just kidding. No, maybe I'm not kidding. Sometimes I do that. In here, it is. Aha. Aha. This is cheating. in every sense of the word. This is made by Elenco, E-L-E-N-C-O, and it is a resistor and capacitor color code cheating card. And so I can sit here. Oh, hi, Jordan. Orange, orange, brown. He gave me the answer. So if I sit here and go, there's a number down here and the color's up here. So if I go 330 ohms, there you go. Orange, orange, brown. This is handy. And this is why I never bothered remembering the colors, because I don't have to. I can just take my little card and there we go. So orange, orange, brown is the one that we need. And that would be this guy right here. Can I have a shout out? I can't because I'm staring at the floor funny. No, just kidding. Well, what up? Staring at the floor funny. That's a mouthful of name right there. But there you go. You got your shout out. All right. So we plop that in there, and the same thing. You gotta spread the legs a little bit, and then you can solder that in. While I'm here, I'm going to get that other resistor, and that is a 2K2. That means that is a 2.2 kilo ohm resistor. God, I almost know this one. Oh, on the back side of this, so the front does resistors and capacitors, and the back side does inductors. So if you don't have one of these, you should get one. They're hard to find, and I thank my dad very much for finding me another one, because I was a kid, and then I lost it, and then he got me another one, and that's just amazing. All right, so 2,200 ohms. So that's going to be red, 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 red. Here we go. Red, red, red. Red, 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 red. Throw that in there. And remember, guys, this is an Ask Me Anything, so feel free to ask me anything. Now, sometimes you can bend I guess you could bend the legs in too. In, out. How do you like your legs? Do you like them in or out? I guess I'll bend these in. Okay. A little bit of solder. Oh, the action's down here. All right. All right, and then I'll take my, what were these again? Diagonal cutters? Flush cutters, flush cutters. I will take my flush cutters, and nip, 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 nip. Okay. So we have soldered on so far 8 bus slots, 8 capacitors, an LED, 2 resistors, and a reset button. And that has taken us an hour and a half. It's because I'm talking, but that's okay. I am enjoying myself, having fun, and I hope you are too. You. I am filming this. I'm filming this on my recently purchased camcorder. It's not new. It's new to me. I'm poor, so I have to buy used things, but it works. I got a second camera here for more angles. So I'm filming the assembly of this. So if you feel that you're missing something and you're really interested in this, or you've ordered one for yourself, do not worry, because I will be covering this in detail in a future video if I get around to editing it, because I have a few videos to edit. So it'll be in there soon. Okay, I think besides the 7805, which I have to get up and get, we're pretty much done with the motherboard. Let's see. Let me check just to make sure. Jumper. Oh, okay. They put a jumper. I guess you jumper this if... Jumper links or resistors needed if slots 1 and 2 or 7 and 8 are used. Where? Oh, I see. Well, I'm going to have to look this up online and see. And with that being said, I probably should have done that first. I see what they're doing. So they've separated out the bus lines on here to where you have to jumper these across if you want to use the outermost slots. And I'm guessing that's for termination reasons. So we'll have to investigate that later. That doesn't require any more parts that we need to solder on right now. Barrel jack. Oh yes. So I'm English, not French. Oh man. So it does come with a DC jack, and we'll solder the DC jack on now. This one may not. Okay, this is going to be difficult. Can I just lay the board down? Cool. All right, it'll stay in there like that. So what I'm going to do is solder one hole. That's a big hole. Okay. And then I will position Mr. DC jack. Use square. That looks pretty square. Okay. What is the name of that resistor color chart? It is made by Elenco, E-L-E-N-C-O. I have no idea where my dad got it. Oh, there's a model number on here too. CC100, and that C is in cat. If somebody finds these online, if you could do me a favor and drop a link to them in the YouTube live chat, that'd be fantastic, because I'm sure there's some people that would love to purchase those. And it's a great way to cheat. How many bits is this computer? This is an 8-bit computer. So translation, not very powerful. It's not. I'll admit it. It is not a speed demon by any means. It is very akin to what a modern microcontroller has, and that's kind of what I like to think of this as. And I don't mean speed-wise, but my point is that a modern microcontroller in a single chip has a CPU, it has RAM, it has ROM, which is where you would store your program, and it has like a timer and counter, it has interrupts, sometimes they have analog to digital converters on them, all kinds of stuff. But all of that stuff internally is already glued together. It's already ready to use out of the box. And you just plop your code on there after hours and hours of head scratching and troubleshooting and breaking things, and maybe even frying a couple of parts, you'll get there. However, this is exactly like a microcontroller in every way, except everything is broken out separately. So our ROM goes on this board, our processor is on this board, our serial interface, our UART, is on this board, our RAM is on this board, and this board generates the clock signals. So all of these components are nowadays consolidated onto a single chip. But if you wanted to experiment with how RAM works, you want to do use DRAM instead of SRAM and experiment with that, you can. And there's no reason why you can't do this on a modern microcontroller, honestly. But I like the different approach to doing things sometimes. I figured this would be fun. This is a good, relaxing afternoon project. All right. So we have our DC jacks soldered on. The only things really left on here are 2 capacitors and our 7805. Oops, can't see me. 2 capacitors and 7805. So that is the only thing left, and that would allow me to plug 12 volts into here and regulate it down to 5. There's a jumper here within the footprint of the 7805, those 2 holes right there, that allow you just bridge across that, and you can plop 5 volts directly in on the DC jack, and you're good. You don't need a regulator. Switching regulators in there, probably what I'll eventually do. But for now, I'll throw the 7805 in because I don't care. So now we have these. This is cool. What I like about this kit, and I was kind of worried about this, but it was included, is all of the ICs are socketed. I like this because I like to catch things on fire. So it's important to be able to have the capability of changing out the socket or changing out the ICs without, excuse me, doing a bunch of soldering. Ooh, do I want the sockets on first? Let's evaluate this for a second. Pin 1 is there. Now, these are the headers that interface these little cards with the system board. That's kind of interesting that these are longer than the cards are. Let's see. Do a quick gander, see if anybody's got any questions. Hey, man. Hey. Handy mnemonic for remembering the resistor color code. Bad boys rape our young girls, but Violet gives willingly. Which translates to black 0, brown 1, red 2, orange 3, yellow 4, and so on. It's on par with a 6502 and a Commodore 64. So it's like a car computer. No, this isn't really like a car computer. I guess you could, though, if you wanted an 8-bit car computer. Actually, is the ECU in the Corrado 8-bit? It might be. I can't remember. No, I don't think so. It might be. Color chart is available on Amazon. Can't paste links into YouTube chat. Come on, YouTube. I guess I understand why. I will make a link available later somehow, maybe in the video description, so you guys have that. Okay, yeah, at any rate. I'm checking to see, okay, those are the full length. They must have just made these shorter because they didn't need to be longer. Question is, which way do these go through? Decisions. So the idea behind this is this is going to go in here something like this. Pin 1 where pin 1 goes. Let's see. Oh, pin 1. Pin 1. Bear with me a moment. I'm just doing some comparisons here because I noticed in the pictures of the computer that some boards were plugged in, the components were facing one way, and then some boards were plugged in with the components facing the other way. And so I'm just making sure that there isn't anything weird going on here with that. And okay, so that is the case. These are designed in a way where they have these going through and it pokes through like that. Because if you, I mean, you can put these on either side, and then with that, you can kind of adjust which side of the slot the little card is going to sit on. And so you obviously want this to work in a manner that's most easily accessible, right? And everything needs to fit. What I'm going to do, I think, given that some of these have components on opposite sides and whatnot, is I'm just going to solder these like I would solder the rest of the components, where the solder side is on the same side as the rest of the soldering. Cool. Bring the vintage back. I think that was the Digifont and the VW 1.8s. Yes, that is what I'm referencing. Digifont 1 is what the couple of my Corrados use. There is a gentleman that frequents the IRC channel that actually did a significant amount of reverse engineering of the Digifont 1 ECU, which is really awesome. He's like the smartest person I've ever met. Fantastic guy. Okay. This isn't going exactly to plan because, well, the connector is kind of a strange one, right? And the board's kind of strange in the sense that nothing here is square. I can't just do what I did with the motherboard and stick all the stuff on and sit it flat on the desk and solder everything. So you got to put a little bit of extra effort into it. Oh, I got closer. I'm close. Close, but no cigar. Not yet. All right. Make this one a little more upright. There we go. Now I can finally close the gap. Put it flat on the board. Cool, just like that. You know, I think what I'm going to do is just take my... They're gone! Gone! Oh, crap. They're not flush cutters anymore. Well, luckily, in the interests of keeping the show going, instead of spending 10 minutes looking for a pair of pliers, I will just pull out another pair of flush cutters. I don't think I'll see that header ever again. Okay, so this is our ROM board. This takes a 27C512 ROM. You can use a classic 27C512 EEPROM if you like, or you can use a flash equivalent. I think this one is. I usually use the SST brand, the SST27SF512. This one is an Atmel AT27C512R. R, matey. I don't know if this is pre-programmed with the basic interpreter or not. We will find out. We will find out in due time. Okay. Oh, look at that. They were under the motherboard. I'd like to reiterate that I am not under the influence of any mind-altering substances. Maybe that's why I'm having difficulties. I'm just kidding. Okay, so let's get some chip sockets out. And I'd like to remind our viewers that if you have any questions, comments, concerns, or suggestions, feel free to hit the YouTube chat with them. I am monitoring it live. You can also join us live in the IRC. That is webchat.freenode.net. The room name is #DoogieLabs. And enter your desired nickname. And you're there, right? Got it right this time. Oh, come on. Come on. These do not want to separate. They are hanging on. Hanging on. There it goes. There's that one. There's that one. Would an 08 Pontiac G6 be a good car? I don't know. I honestly don't know. I would not my personal preference of car, really. But with that being said, the G6. Oh, and by the way, I'm using the I'm using this other board here as a bit of a spacer because the right angle headers stick up past the chip sockets. So I'm just putting this like this over the chip sockets so I can set it flat on the table and have everything protrude through evenly. And then we'll do our typical get the corners. And then we'll go back and fix it up. Okay. Now we got our corners. And remember, don't push too hard. Because if you push really hard, sometimes you can pop the solder pad off the circuit board. And then you got a lot more issues than you did from the beginning. Okay, one more. And we're there. So would a Pontiac G6 be a good car? Probably. It'd probably be okay. And the reason why I say that is because that is a continuation of the Pontiac Grand Prix, basically. It superseded that, essentially. And that was a pretty solid car, and I believe it's the same platform, so it should be okay. But with that being said, the given is that you know that General Motors, as an American car manufacturer, builds cars that fall apart after 100,000 miles, roughly. And I'm not saying that it's not going to get you from point A to point B. What I'm saying is that you're going to use with those. Maybe your switches will stop working. The cruise control will stop working. Stuff like that. Usually, typically, unless you own like a Chrysler Sebring, typically drivetrains on American cars are solid enough that they'll work just fine. I had a gentleman explain to me once how General Motors tests their engines. I found it quite fascinating. Basically, the engineers would load the engine into the test cell, which is an engine dyno room. Let me back up. So they develop a new engine, and they want to know, is the engine worthy of putting in a car? Is the design proven? And how they prove that design is they put the engine on an engine dyno, engine test cell, and they start the engine, and then they ramp it up to full throttle. So red line at full throttle. And then they shut off the lights, and they come back a week later. And if the engine's still running a week later, it passes the test. So 7 days, wide open throttle at red line, maximum load. And of course, you could never do this with the engine in a car, because how General Motors does it is they're using heat exchangers for the oil and the coolant to keep the oil and the coolant from running away thermally, which is what would happen in a typical car if you were going to try and do this. So keeping those temperatures under control allows them to perform a test like that, and actually be able to have an engine come out of the other side. So that's really interesting. It just goes to show how much crap an engine has to endure in a passenger car throughout its lifetime, because they put it in a room and they run it for a week straight, and people somehow still manage to break them. So that says a lot. I don't know if all car manufacturers do that, but I know that General Motors does. All right, we have our ROM board assembled, so that's with our 27C512. I guess I could go ahead and insert the chip. So we are putting our first IC on. Now I haven't fully soldered in the edge connector, because what I'm going to do is assemble these boards, and then I'm going to try them in the motherboard. And if I feel like some parts are too close together and not very accessible, I may flip the pin header around 180 degrees. Okay, and a 7.4 LS32. Let me make sure. That's the RAM. Okay, is there one that's different than the rest? Oh, there's, okay. TO4. Here we go. 7T3281 is the one that we got to go in there. Bill Owen, buy VW or Honda. My 97 Honda Accord has 287,000 miles. That's fantastic. And most Honda Accords do go that far. It's kind of like the Camrys in the early 2000s. I mean, those were the workhorses of the working class, of the middle class America. So they did exactly that. They got you from point A to point B without questions or issues. And they do it well. All right. I'm going to solder the chip socket on first on this one, so I don't have to play the let's hold it and hold our tongue at a funny angle. We can just solder it straight on. Okay, thanks. Curtis Smith. I heard Pontiac G6s are cheapies. Don't get me wrong, they get good gas mileage and the motors are relatively reliable, but they are difficult to work on yourself. Coming from a Eurocar guy. I think you're going to find that that is the case with most of, if not all, new cars. They are designed with the intent that you're going to take it to an authorized repair center to have service, right? So the authorized repair center is going to have all these specialty tools and stuff. And so, I mean, of course, it's designed with some extent, or to some extent, with service in mind. They don't ignore that completely, but when they design it, the consumer isn't the person that they have in mind servicing the vehicle. And so a lot of special tools, more than ever, are required to a variety of cars. And it is just inherently difficult, it seems, to do anything these days with something new. And everything is always built to the lowest price point, it seems, at least with cars that are under $100,000. So cars that are obtainable by regular people like you and me. And that's coming from a Eurocar guy as well. All right, so right now we are soldering our CPU socket on, and then we will insert our Z80 CPU. After I solder the header on. And then after all of the soldering is done, this is going to get a bath in isopropyl alcohol with a scrub brush. So all of the flux and nastiness that is left from soldering is washed away. Isopropyl alcohol, a plastic bristle brush, and some tap water does pretty good. Actually, what I should do is not put the chips in the sockets until after I clean them. Oops, because I've already put these in. And the reason why I say that is chip socket has a lifetime. And what I mean by that is a chip socket has a certain number of times that you are allowed to insert or remove the chip in that socket. So to minimize damage, I'm going to wait until after I've cleaned all of these. Okay, we'll do the same thing on this one. That was bent slightly, so let's go this way. I'm going to be choosy. Choosy. Okay. Now that helps a little bit as far as the squareness goes, using the chip socket first, at least with the CPU board. I have a 95 Volkswagen GTI with the VR6, and that has 200 and I want to say 230,000 on it, between 225 and 230. So it's almost at 250,000 miles. We're getting there. It'll make it, no problems. That's been a very wonderful car. Pretty reliable. I mean, I only had one issue with it, and it still got me home. The issue was the clutch fork not broke, but it cracked. And it cracked in a way that when you would push on the clutch, it'd push the clutch in, and then the fork would bend back. But it would do it slow enough that you could actually feel the clutch engaging after you've pushed your foot to the floor. So it's kind of an interesting issue. And luckily, because I have Corrados, I had a crap load of extra parts on hand, so I had an extra clutch fork. In, I actually welded it up and made it stronger. So problem solved. Oops, I forgot a pin. Cut it off one too long. All right, so that is our CPU board. Oh, we have some jumpers to put on. Almost forgot. Now the jumpers is something that's not included in the kit, and the reason why is because they expect you to just solder some links across there and be good with it. So I'm going to not do that and instead opt for a little header that I can put some jumper links on, because in my experimentation I'm going to change the configuration around several times, I'm sure. So I want options, and options we shall have. Oh. I think I have to cut one shorter here or something. Let's see. This is all digi-key parts. These are for the option boards that should be here Monday, actually. All right, so we're just going to cut a couple of these shorter, I guess. No big deal, man. Actually, let's see. Can I pull these? Needle those. I'm going to have to cut this shorter. It's one row too long. And I think these will cut fairly cleanly, but I'm going to pull the last two pins out. Actually, maybe I could just pull the last two pins out and solder it in. Would that look okay? It might. It might. But I am a perfectionist. Okay, we are going to have bits and bobs all over the room by the time I'm done. You watch. We've already lost one pin header, and now some random plastic piece. Those of you who are just joining me, hello and welcome to the Doogie Labs live stream. This is the first time that I've done a stream by myself in forever. Man, I think the last one was Data McFirehosen, which I had fun doing. I don't know if you guys liked it or not. A couple people did. But today we are assembling a Z80 8-bit kit computer from parts. And while I'm doing this, this is an Ask Me Anything episode. So if you have personal questions or comments or concerns or suggestions, or you need help fixing your computer, you have an electronics question, you need help fixing your car, I am watching the YouTube live chat box, and I am also in the IRC. Point your web browser to IRC. Again with the IRC thing. Point your web browser to webchat.freenode.net. The room name is #DoogieLabs. And yeah, ask me anything is the theme of the evening. Okay. We are soldering in our resistor on the CPU board. It is a 3.3, which is red, right? So if we use our cheater thing, a 2.2K in place of the 3. Oh, I did, didn't I? I totally just did. Orange, red. That is not orange, red. No, it's this one. And this is the fun part about doing this live, right? You get to watch me screw up, and you can laugh at it. So now we have to unsolder this. Do I get out the solder wick? Let's see if I have to. I'm going to try and cheat. I'm going to heat up both sides reasonably. Oh. No, I think I'm going to have to get out the solder wick. No! Huh. All right. The solder wick is in my electronics box, which I'm going to have to get up and go retrieve. Well, I got pretty far before screwing up. All right. This is my electronics box, which is actually a tackle box, an elaborate one. And let's see. There we go. Solder wick. Perfect. I got all kinds of goodies in here. This is my on-the-go electronics box because when I came out here from Colorado, I couldn't bring the entire lab with me. So I bought a box and put the ancillaries in there. And that's worked pretty good, actually. I'm happy with that. My friend has a 98 GTI VR6 Ginster, still running strong. She drives it hard. It has around 160K now, I believe. Best engine I've ever worked on for someone. She runs that thing into the ground, has rust on the frame, and needs a front end swap from a Jetta since it rear-ended a city bus. Wow. Yeah, those are pretty durable, the MK3s. And the 98 was the last year, I think. All right, what I should do is turn this up. We'll go up to 750. That is my typical desoldering temperature. It's important when soldering and desoldering. There's two different temperatures for that stuff, right? So desoldering is obviously a higher temperature, or at least for me it is. Okay, so we are 100 degrees higher. The soldering iron goes between the wick and the part that you're trying to desolder. It helps to have helping hands. How many people have done this? Used the solder spool to hold the thing you're working on. You can tell that's my go-to. Electrical tape it is. All right. Improvisation. Okay. Let's see if I can do this. Evidently, I have Parkinson's today. Is that a solder sucker? I don't know if I do. Actually, I'm pretty sure I do. I just don't have it in that box. I'm pretty sure my dad sent me one. I'm almost positive he sent me one. I'll use this for weight. I'll use this for leverage. There we go. Got one side. I need to buy me a helping hands thing. Look at that. Didn't have to cut it out. All right. Oh, I have a private message. Oh, Rocco, you're funny. Orange, orange, red. Right? We didn't guess this time. We used our handy dandy resistor color code calculator. Orange, orange, red. 3K3. Right? Right. Or am I wrong and I soldered the wrong resistor in a second time? Okay. Well, we're going to back down to 650. Another thing I do when I'm soldering that I didn't mention earlier is that after I've applied the solder, I leave the heat on there a little bit longer, which allows the solder to wick into the other areas because you're not removing heat by adding more solder, but you're allowing that heat to transfer into the joint. And solder loves to follow heat. And so it's going to wander its way in there right behind it. Okay. Boom. So that is our assembled CPU board, which is basically the processor, some jumpers, and a resistor. And here is our processor. So I'll pop that out. And that goes in there like that. And like I mentioned earlier, I'm not going to put I did it on this one, but I'm not going to put the ICs in yet until after I've scrubbed these boards from all the flux and everything. So there's that guy. What's next? So far we've done the RAM and the CPU, or not the RAM, the ROM, not the RAM. This is the RAM. This is the RAM board. Okay. So this one takes a 74 LS32 and a 74 HCT04. And of course our RAM, which I believe is 32K. I believe it's 32K. Okay, so chip socket. And the other chip sockets. Make sure the notch for pin 1 is in the correct orientation. And it is. I'm going to use my paper trick that I did earlier. There we go. So keep them coming. Who's got another question? Let's hear some more questions. I'm actually really entertained talking and answering your questions while doing this. Normally I just listen to some music or watch some YouTube videos, which I enjoy, don't get me wrong. But I like helping everybody out too. I really enjoy answering questions and talking to people, and it's a lot of fun. It's how you learn things, by being interactive. I can sit here and show you things, but I far prefer the interactivity. So right now I'm soldering the corners of our chip sockets on the RAM board, which comes with a whopping 32K. Not megs, not gigs. No, 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 no. K of SRAM. That's not much. I mean, you could actually fill that with a notepad file. All right. Bloop. Let's see. Yeah, I'll put this on now. For those of you who are car people, I do have more car stuff coming up in the way of videos. I apologize that the overwhelming amount of my videos have been about, well, the hovercraft recently. I've been really working on that a lot, and it's a lot of fun. One of the things that I'm doing with that is I'm announcing a GoFundMe page. I need some money for research. You know, I'm a broke bastard, so to continue developing the hovercraft, I need some funds to do that. And basically, what do I need to develop on the hovercraft? Well, I need to come up with a skirt system. So inevitably, you're going to need to change the skirt on it. And so I would like to come up, I already have designed in my head a way to do this that is a good solution, but I need to buy materials and I need some time to do it. And what I want to do is actually manufacture these hovercrafts because they're a lot of fun. And every time I go take it to a lake or a parking lot and I'm running it, it always draws a crowd of people. They're intrigued. I've been asked several times, hey, where can I buy this? And so I've decided, you know what? I'm going to make it. I think I'm going to make it. I don't think so. I am going to make it and offer it for sale. But I need to finish research and development. So having a skirt that is quickly changeable, coming up with a method to mass manufacture skirts, so that way they're inexpensive to replace, to obtain and replace, which I've come up with as well, including better materials. That's what part of the research money goes to as well, is sourcing better PEVA skirt material from a manufacturer. I want to try a few different materials. Part of the money would go towards building the skirt making machine, which I've also got a design for. And then, creating a business from this and offering this up for sale to the public in a pretty much ready to run configuration. So if you haven't seen the GoFundMe page for that, don't sweat it because I haven't actually really officially announced it on my YouTube channel yet. There is a link on my Facebook. Yes, I have a Facebook, and that is disappointing. Anyway, my Facebook is Doogie Rick, just like my YouTube username there. And there's a link to the GoFundMe page, and it has on that page is a lot of detail on how that project works, what the expectations are, what needs to be researched, and all of that good stuff. So if you guys are interested in that, follow along, and hopefully that can be available very soon. If I got the funding, like let's say tomorrow I had all $25,000, I could head back to Colorado. I would rent a small warehouse and build the machines I need, do the research I need, and sell them. And if I get that $25,000, And let's say if I got that within the next month, I would be able to take orders for 300 units and deliver them by Christmas time. So there's some food for thought there. Maybe there isn't a lot of interest in those, in which case I'll have to take a different approach, I guess. If people still want to order them, you know, and regardless of the state of the research, I could still work something out, I guess. Let me know. All right, so our RAM board is assembled. This is just 3 ICs on a board. There's no anything else, which is kind of it. I mean, I would expect like some decoupling capacitors maybe, or some other stuff, but there's nothing on there. It's just incredibly simple. So, okay, cool. This leaves us with 2 more boards, and then we have the base computer kit together. So this one is a serial board. This is the serial interface between the computer and, you know, whatever else. So in most instances, this is going to be between this computer and the serial port on your computer, so you can type text in and stuff. So this is the main input-output interface. And so this uses an MC68B50 UART. And then we have our 7HC TO4, so that ties it in with the bus. This chip is not included with the kit, but I have one, and I think I'll populate it. We'll see. This is a Max 232, so this converts the 5-volt signal level into, what is it for RS-232? 9 and -9? It's a 9-volt signal level for the 9-pin RS-232. Well, it's not 9 pins, I guess, but 9 volts is the signal level for the RS-232 serial signals. There's an FTDI header on here, so if you have, you know, an FTDI board, you can just plug it straight into there, and then you don't need the Max 232 or whatever else. But I think I'll populate the Max 232 so I have a serial port that fully functions as intended. This way I can interface it with other things outside of another computer. So start with our pin header. The board interconnect. All right, wait. Start with our IC sockets. I'm sorry, I'm getting ahead of myself. Because we determined that soldering in the IC sockets first is a better approach over over the board interconnect. And then we'll use our magic paper. Actually, before I do that, I'm going to see if I have a socket for the Max 232. Obviously, they don't include a socket because they didn't include the IC. I will have to provide my own. For those of you who are just joining me, hello and welcome to the first Doogie Labs live stream I've had in a really long time. Long overdue, I suppose. Right now, we are building a RC2014 Z80 Kit Computer. So this is a 8-bit retro computer that you build from scratch, basically. It comes as a bare set of boards and components, and you solder it together. And it's been a lot of fun assembling this so far. And while I sit here and do the mundane task of soldering things, it is an Ask Me Anything. So ask me anything. Cars, computers, electronics questions, personal questions. Any questions, comments, concerns, or suggestions are very welcome. I am watching the YouTube live chat, so you can just feed your stuff right into there, and I'll get it. I'm also in the Freenode IRC network. The channel name is Doogie Labs. So looks like we've had a couple of things. Earlier I mentioned that the RS-232 voltage levels were 9 volts. Rocco says usually ±13, but can be ±3 to ±25. So there's a bit of variance in there. Doogie Labs, this reminds me of the early days when you first joined the lab, when it didn't suck there. You used to get on a regular basis and build something while we talked to the IRC. Those were fun times, and so is this. It is. I do. I really like talking to you guys. It's a lot of fun. All right, so I'm going to get in my electronics box over here. Not that one. Need this one. Boom. All right, and in this box, we have some items. Okay. How many pins is a max 232? 18, I think. 16, 18. Because these are 20. Well, this is a 20. I think a 20 is too big. A 20 is too big. Okay. How about an 18? It is a 16. I don't know if I have a 16. 18? 18. Really? No! Okay, well, there is more than one way to cheat at this. So, here's what I'm going to do. I got two 8-pin sockets here. So if I take, let's make sure they're oriented correctly so we don't put the IC in wrong. I got two 8-pin sockets here. So we'll put them end to end maybe. Is this allowed? It helps if it's oriented the correct direction. What a hack way to do this. This is where I express my lament for not having a 16-pin socket. Okay, guess we're going to use two 8-pins. I also have in here some of this, which is cut to length. Oh man, I just don't know. Don't know. Rocco asks, when did you screw everything up, but no one ever found out it was you? Well, I couldn't tell you because then somebody would find out. When did I screw everything up, but nobody found out it was me? That's a tough question. I don't know if I've ever screwed everything up. I'm totally joking, by the way. I have screwed lots of things up a lot of times. Nothing specific comes to my mind, though. Screwed everything up. Use the two sockets. Yeah, I opted to use the two sockets. I figured that was cleaner than being a cheap bastard and using the pin headers. So we're going to align these two sockets so they look like one socket. Close enough. Do things plug in? Scene 2. All right, we'll go ahead and lock those in place. Boy, it's 10 o'clock already. This whole daylight savings time thing sucks. Like, I'm happy that it's daylight later now. I don't have to go home in the dark, but I'm just annoyed with the fact that I'm wide awake and it is now 10 o'clock. Well, I'm usually wide awake at 10 o'clock, but bed is really not an option right now. Okay. Solder, 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 solder. Boy, I wish I had my other camera so I could give you all a fantastic view of what I'm doing. I apologize for not having it. Oops. And a quick reminder for those of you who have just joined, tonight is an Ask Me Anything, so don't hesitate to ask me anything. All right. So while I was talking, I totally forgot to push the one chip socket completely down before I soldered it the rest of the way. It was 99.9% of the way there, so nobody will notice, but now I know it's there. So I'm going to, there's no way that this is going to work. I've soldered all of these. Okay, all I'm doing is burning my finger. Oh well. Speaking of burnt fingers, that is a burn on my finger. Doesn't hurt though. Okay, so those are the sockets. Let's check the assembly guide. Now's a great time to ask questions. Someone hit me with another question. All right, we'll do that in a second. R1, R2, and R3 are 2K2 resistors. Now, 2K2 would be red, red, red. How do we know this? Because I screwed up earlier. So red, 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 right? 2.2 kilo ohms. So red, red, red. And you can see there that it says, well, you can barely see there that it says 2200 down here, red, red, red. So we know we have the right resistors. And now we will do this. Now, since R1, R2, and R3 are all 2.2 kilo ohms, we know that our last three resistors go here. So we will plop those in. And these, now on the other boards, the resistors were mounted axially, right, on their side flat. These are mounted radially. So we take one lead, loop it over the end there like that, and insert into the hole. Which way do I want these to face? Probably that way. We'll go with that way. And then just like earlier, bending the leads underneath so the component stays in place on the board while we solder. Okay, there's one. We'll do another one. Have you talked about the top secret, not so secret project? Which one? If you're asking about the hovercraft, yes. Yes, I did. I did just touch on that. Ooh, I'm going to flip this around, actually. No reason in particular other than on the board, there is a circle in the silk screen. And I want the circle on the silk screen to be where the resistor end is down instead of the leg. Yes. Well, just like that. Okay. And then we took our other one, the one I just looped over. Not that you can see that. And poke her on through. All right, one more. Whoa. So who in here orients all their resistors the same direction when they're assembling something? Who here is that OCD? And then my follow-up question to that would be, as a kid, were you that kid that had to find Lego bricks of all the same color when building like a Lego house? All right, so I'm going to solder each resistor, one leg of each resistor, so I can orient them a little better. Cool. Lock them in place. For those of you who have just joined, hello and welcome. Tonight is an Ask Me Anything night while we sit here and assemble the Z80 Kit Computer. And I just got solder on all the things. Had a couple of legs crossing over each other here. So there we go. Take my flush cutters. We'll cut that leg flush. Okay, and now we can finish soldering the rest. Okay, looks good. Don't know if we're going to be able to power this on tonight. We're damn close to wanting to try this out. But it's also getting late. It's not really getting late, but the fact that I have to be to work tomorrow makes it so. Okay, we'll scooch these out of the way. And now I'm going to finish the rest of the IC sockets. Boy, I think I'm going to have to go buy some alcohol. I don't think I have any isopropyl alcohol. Or does it need to... might need to be like denatured alcohol, actually. Now that I think about it, I believe that's what I was told to use. For anyone wondering what I'm rambling about, I'm talking about after the board is done being soldered together, taking denatured alcohol in a plastic bristle scrub brush and using the alcohol and brush to scrub all of the extra flux and crud that is on the board from the solder process. I wish I could get a close-up view of my soldering, because the way that I do this is like I tin the iron while I'm heating the pad and leg of the component, and then solder the component, and it all happens in a very brief moment in time. I'll have to figure out a way to show that to you guys. And y'all can make fun of how bad my soldering is. All right, so that is the serial board. Is there anything else? Might be, since I'm adding stuff. Optional RS232 components. I need to figure out what capacitors go in those holes. Oh, duh, we're not done with this. We got to stick this on still. Well, you know. Ooh, the board isn't cut off on that end quite correctly, so. See, I almost did this first, and then I was like, no, we got to do the IC sockets first. And I did the IC sockets. And then ADD happened, and I did the resistors, and now that I'm here on this, I have to space it all funny. No problem, man. Guy says, Doogie, I have a bottle of liquid rosin flux here, and it's using ethanol as a solvent. So yeah, denatured alcohol would work just fine. Good to know. Thank you, Guy. Ether. Oh, ether is usually fine, but I use isopropyl. That's funny. I was like, ether? I could use ether? No, you shouldn't. Okay. And I'm just going to solder the end pins, the 2 pins on each end for the bus connectors, right? Because like I had mentioned earlier, I wasn't sure if I wanted to flip these around or not. All right, cool. We are very nearly there, guys. Ah, yes. All right, so RAM, ROM, CPU, serial interface. There's only one thing left, and then we have a computer. And that is, we need to generate a clock signal. So we're going to assemble our clock board. I'm going to start with the chip socket. And for those of you who are wondering what computer I am assembling, this is the RC2014 Z80 8-bit kit computer. You can get this computer from rc2014.co.uk. The gentleman that developed this computer is just another electronics hobbyist, enthusiast, and decided he wanted to engineer a little Z80 computer that was modular. And I really liked it, and I like supporting people like that, who do DIY projects, that like to offer them for sale and help others out. So I figured, what better way to spend my hard-earned money than to invest in somebody else who is taking the initiative on their own to bring this to the world and get something fun and educational for myself. So it works out pretty good, I think. It's a good trade-off. What am I going to do with my Z80 Kit Computer? Well, I think I'm going to use this to make a clock, and not just any clock. It wouldn't, any clock done Doogie style would not be a regular clock. That's for sure. All right. This time I remembered to use the pin header. Now, or not use, but put it on next. I noticed an interesting quirk. Let me make sure I don't have a loose part here somewhere. Okay. A spare 16-pin header on the back. Okay. So on the clock board, it says reset switch and R1 may be mounted on backplane or clock PCB according to user preference. Resistors are mounted end on. 8-pin header may be supplied as 2x4-pin headers. Should be fitted before the crystal. Okay. So that makes sense now. They said 2x4-pin headers. Except I don't really have a 2x4-pin header. I think they were assuming the cutoffs from the others. So do we use one of these, one 6-pin and one 2-pin, or do I cut 2 off of one and use the 4 and we have 2 4s? Decisions, all complicated decisions. Okay, here's what I'm going to do. I'll probably just cut so it's 4 and 4. So that way the load is distributed, the mechanical load and stress is evenly distributed across them. I'm going to test fit the crystal to see if it runs into anything goofy. Doesn't seem to. Okay. Now, one interesting thing about this crystal is the flange that is on the bottom of the case almost touches that hole above it. It's a resistor hole. So I think I'm going to have to space this guy off of here a little bit. What are the resistors for? And do I have all of them that are required? One, two, okay, R2 and R3 are what I need. So what's really nice about the loose and fast assembly guide is that on each page is a schematic of the board that you are assembling. So, and remember, I didn't read any directions putting this together. So far, it's all been common sense for me. They have an assembly guide on their website, which you can definitely use. But I like this. This is nice because it's not a step-by-step thing. It just has the important notes. So, and sure, it's probably not all-encompassing, but it'll tell me what I need to know for sure. Okay, so I need to solder some headers to this. We'll do that in a minute. Or I already read that one. What kind of skill level, or I'm sorry, what level of skill would you say this project takes to assemble? I would say that a perfect soldering skills and basic electronic skills could assemble this kit. Every single component is through-hole parts, so there's no weird surface mount soldering. I can't speak for the directions, I guess, because this is not a step-by-step instruction guide, but it's pretty straightforward. And I think with following a video like mine, a person who is new to electronics should be able to assemble this with relative ease, certainly. Okay, so back to earth from my tangent. We said, I think I said R1 was not used. Right, because R1 goes with the reset switch. So R2 and R3 are what we need. And according to this, R3 is 1K and R2 is 1 mega ohm. Now, I know that R3, right, it was R3 that was 1K? Yes. I know that 1 kilo ohm is brown, black, red because I use these all the time. So if you got your little cheat card, right? Brown, brown, there it is, brown, black, red. And that makes 1,000 ohms. These things are awesome. All right, we'll take our legs off the end here. We'll loop over the end. And I said that 1K was R3. Bend these out. We're going to get rid of our crystal for a moment. I have the crystal poked through there. And in the assembly guide, it says to solder the headers on before soldering the crystal on. So we'll want to be sure and do that. I don't know if it's because it just physically gets in the way or if it's sensitive thermally. Probably not. I don't know. How are crystals thermally? Are they fairly resilient? Are they more resilient than LEDs? All right, R3. This comes to our final resistor in the kit, which is 1 mega ohm. It should be. Let's verify. So I'll grab my cheat thing. So 1 is brown. We know that. 0 is black. So we know that. So we just need our multiplier. All right, 0, 0, 0, 0, 0. Okay, so 1 mega ohm is brown, black, green. And here we have brown. We have brown. We have brown, black, green here. All right, and this was R2. Double check that it's R2. R2, 1 mega ohm. Oh, yeah. So plop that bad boy right in there. Give this a little solder. Boy, I need to get me some helping hands. Can I get an intern, please? hold this tiny part while I stab hot things at it. Thanks. Get out my flush cuts. Okay. And then I'm going to move this 4-pin header over to here and solder that in place. Then we can get our crystal on. Done. Okay. Put the crystal in. And for those of you who are just joining or haven't heard me in a while mention it, this evening's broadcast is an Ask Me Anything episode. So please feel free to ask me anything. Anything at all. All right. I'm a terrible singer, I know. Boy, it almost works out easier to put the crystal on the back side. Am I allowed to cheat like that? So when I put this in the front, oh, I guess it fits, sorta. So there's a gap there. And one edge of this kind of smashes into the plastic there, and the other into the resistor. So I guess it really won't short out on anything. Screw it. I don't know if we're going to really be using this clock module or not. With the options that I'm doing anyway. Oops, that went flying. Yeah, I don't recommend the 70% isopropyl alcohol. I am a 90+% person myself, and detritus mentioned that because you don't want to have funkified residue on your circuit boards after you have thoroughly washed them from your solder job. I need to make a solder fume extractor fan. Maybe I'll do that in a hangout later. Oh crap, it's 10:22. Why did I look at the clock? I'm having way too much fun. Probably going to be up till 1 a.m. anyway. Screw it. All right. That is one assembled clock circuit. I got another 4-pin header to solder on here. And then our clock generator board is done. This generates the clock signal for the whole computer. One of the things that that one gentleman made that I'll have to put some links in later to, he built a board that allows you to single step through the clock, which is very helpful in programming. So I think I might make that nice little tool. I wonder if I should make this accessible to others, like on the internet or something. Could be fun. That could be fun. Oh, come on. We got some schmoo hanging off of this one. Okay, let's try that. Ah, Mr. Bent Pin. Not so bent anymore. Okay. All right, we'll solder that together. Am I entertaining y'all enough, or do I need to like put some music on too? Probably won't put music on this time, but would music be something you would want for next time? Or is my sexy voice entertaining enough? Probably not. It doesn't entertain me, let's just say that. But you guys do. I love all of you. Okay. Bam. Wham, bam. Thank you, ma'am. Look at that. I like how I hold my hand on the back of this, assuming that the camera has a focus function. Oh, you know what? I do this for you, my viewers. Aw, yeah, look at that. So that is the clock board. Okay. Here is the serial board. There's my two 8-pin sockets stuffed together. UART bus interface and the FTDI header, of course. This is the Z80 CPU board, which is basically just a big chip socket and some options up there in the corner. And then this guy is our ROM board. So this actually holds the program. So there's our ROM. This is the one I actually put the chips in, which I regretted doing because I need to clean this before we actually put all the chips in the sockets and try and power it on. Okay. Now we have some jumpers and stuff too. Okay. Now first off, I said I needed to solder some headers on something. So let's see. We're almost done soldering. It's only been a couple hours. I don't know what took longer, this or the Mega Squared ECU. 3-pin headers should be fitted horizontally as indicated. Jumpers across these select which 8K bank of the ROM is used. For basic, use jumpers between A and 0 on each one. Pro tip, to keep them spaced evenly, use jumpers vertically between the headers when soldering. Oh, that's cool. I didn't know that. Look at that. See, this is educational. All right, so I'm going to take my length of pin header here, and I'm going to cut 3 off of this one. And I'm going to cut 3 off of this one. And 3 more for good measure. Okay, and then I'm going to insert these into here, like so, like so. Okay, and then we're going to take our jumpers, and I'll put 2 across here. And then I'll bridge the middle and the bottom one by putting a jumper across there. Bam. So we have our headers all hooked together, and they will maintain the appropriate spacing. Okay, put that there. And then it's the same approach as last time. Solder a corner. Solder a corner. Solder the opposite corner. And then we plop these. Ow! Now here, if I use the burned part of my finger, I won't feel it, right? Okay, plop that there. Make sure that's flush. Use the burned part of my finger here. Make sure that's flush. Cool. Burnt fingers eases assembly. Remember that. All right, a little touch up here. By the way, I didn't burn my finger soldering. I burned it on a washer. I don't mean a washing machine. I mean like a washer, like nuts, bolts, and washers. I was taking a fender washer, and a fender washer is not for a car fender. It's a washer that's a really big washer with a small hole, right? I was hogging out the center hole of a fender washer so I could use it as a retaining clip. Did I just bridge those? Yes, I did. Okay, there we go. So I could use it as a retaining clip for a like headlamp holder. And after drilling the hole significantly larger with a dull Christmas tree bit, I decided for whatever reason that I could unbend the washer by placing my finger against the edge and pulling. I guess forgetting that I had just drilled a hole in the washer, right? And it was a little hot. So that happens. Like I knew it was going to be warm. I just didn't expect it to burn my finger. Okay. So that's those pin headers. What else needs soldered? Because we're going to get that out of the way all right now. I guess this is the point where if I want that 7805, I should put it in. Ah, I know. We should plug all the stuff in and see what it looks like. So let's do that. Let's plug some stuff in. Like opened this to the blank side while looking up at the monitor. I'm a dork. Now there was a, here we go. Let's go through that again. Thought there was a one that showed where all the cards go. Yeah. Okay, so with the board oriented this way, and I will definitely double check this before I actually power it on, but for now, slot 3 gets the CPU, pin 1, pin 1. So that's the CPU. The ROM goes in slot 4. So pin 1 of the ROM goes in this way. So these are effectively facing each other. And then that shifts that board over. And I'm glad I did this because I think I'm going to flip things around here. RAM goes in slot 5. So that's the FTDI board. This is our RAM. Pin 1. So it orients it this way. And now the serial board goes in slot 6. Slot 6. So this orients around this way. So those almost touch each other. They are really close to touching each other. Now, one thing I haven't read or looked up, I should say, is if it really matters which one goes in which slot. And I think that the answer technically, well, the answer is yes and no. And the reason why it's no, it doesn't matter, is because the back plane is passive in nature. There's no active electronics on here. So it really doesn't matter what goes into what slot. But on slots 3 and 4, there's an extra width between there, and that allows these things to point at each other. For whatever reason, they have these guys pointing at each other. And that's the ROM. Yeah. And then they have the clock board here on the end here. Ground VCC reset clock. So that goes right there. Okay. Well, interesting. So here is how that looks. And then we'll throw, what did I say was in 5? RAM. And then 6 was the serial. What I'm probably going to do is put the serial here out at the end. Or, well, I don't know, because I got prototyping stuff too. So, all right. Boy, that is all tightly packed in there. So the orientation of the pin headers, I'm okay with, I'm going to say. All right, so here's how this looks. And for those playing along at home, clock, CPU, ROM, RAM, serial. So that looks good. Good, good, good. We can lock the rest of these in place. So I just have a little bit more soldering to do on those. Our clock board's already completely done. So cool. All right. Solder, solder, solder. For those of you who are just joining me, hello and welcome to the Doogie Labs 8-bit computer build kit computer / live broadcast. So I am accepting your questions, comments, concerns, or suggestions. Totally did not solder. I just soldered the ends on this one. I didn't go 2 on each end. There we go. So I kind of screwed up my alignment there. I think we're okay now. So anyway, tonight's an Ask Me Anything. If you would like to ask me anything, I will answer anything. Maybe even answer to anything. Could be interesting. I only soldered 1 on each end on here too, so we're going to plop some in the middle there. Okay. Bloop. Hopefully this is entertaining for my YouTube audience. Eventually we'll do like build an engine live or something, because I do like to do the car stuff. Just a little too much solder on there. I'm going to go back and suck some of that out. I do like uniform solder blobs, because who doesn't like uniform blobs? Boy, I really need a better light. So since nobody's asking me questions, I'm going to ask y'all some questions. What are your favorite kind of videos on my channel? What do you guys like to watch? Do you like everything? Do you like the variety? Did you come for just one thing in particular? Do you find the fact that I have videos about other things annoying when you see them in your subscriptions? All good questions that I'd love to know the answers to. So this is going to turn into an Ask You Anything. Except I don't get to watch you be all uncomfortable when I ask weird questions. Do you masturbate? And if so, how often? Okay, let's see. Guess I could make some music while we sit here. What? Oh, yeah. Actually, contrary to what most people probably think, I don't normally listen to music when I work on things. As a matter of fact, I sit here in complete and total silence. Even when working on a car. Sometimes I do put on the radio and get in my zone, but other times I really enjoy complete and total silence. I don't know why. It's not that I don't like music. Oh, hey, somebody responded. They masturbate 5 times a day. Whew. Oh, man. His right arm's got to be like 4 times the size of the other one. 5 times a day. Well, I guess if it only takes you like 15 seconds, that's not bad. Having a bad day? Nip it in the bud. Jack off at lunchtime. Oh, man. All right. So right now, for those of you who are just joining and probably promptly leaving, I am soldering the final connections for the headers on the cards that plug into the motherboard. I deliberately did not solder these all together in case I felt as if I needed to adjust the way the header was to space the cards out differently. It seems as if that is not going to be an issue. That's that Adam Carolla level. Oh, man. That's funny. I love Adam Carolla. He's funny. Definitely a type A personality, though. A lot of people don't like him, and I completely understand why. As a matter of fact, if I actually had to work with him on a daily basis, probably wouldn't go too well. Okay. Bam. That's one. Now I can actually plug that into the backplane without issue. Oh, that's funny. Reading the YouTube live chat comments. I'm ambidextrous. It takes both, you know. Sorry, bringing down the quality. It's that admirable skin graft time at that rate. You know, I'm ambidextrous too, but I don't know. The right hand just doesn't do it for me. Is it still ambidextrous if you use one hand for some things and the other hand for other things? Because I write with my right hand, but I eat with my left. I'm right hand dominant with sports. I don't know. That's just is weird. It is almost 11. Well, we built a computer from a kit of parts in an evening. Getting it to work can be a whole other project for another video, I suppose. Solder, solder. I don't know why, but I just envisioned a fraternity house with a bunch of dudes at a table soldering things and some drunken guy going, solder, solder, solder. Maybe if solder had, if solder smoke contained alcohol or something, that'd be feasible. Could you imagine how much further along in electronics we'd be? All right, next. Oh my goodness. So tonight is Ask Me Anything. I am watching the YouTube live chat and responding directly to your questions and comments. I am also in the IRC channel, webchat.freenode.net. The room name is #DoogieLabs. And there's a bunch of other peeps in there too. If you need advice, you have a question, or you simply want to tell us a story about your grandma's cousin's brother who, no, we don't want to hear that. But if you have a question, or even something to share, your own retro computing project, whether it be cars, computers, electronics, come hang out with us. We normally do a live stream. So you can get in a Hangout and you can actually hang out with me live. And not even just me, but a bunch of other people, often people who are much smarter than I am, and bounce ideas and questions off each other and hang out and have a good time. It's not a place of ego or arrogance or anything like that. It is not a dick measuring contest. It is a bunch of people who love technology that like to get together and help each other out. So that is what we're about here. Right now I am soldering together a Z80 Kit Computer. This is an 8-bit computer. This entire kit was designed and built, manufactured by an electronics hobbyist in the United Kingdom. I don't know who he is, never talked to him, but I really liked his computer, so I decided to buy it and assemble it and have a play with it. So that is where we are at. If you want to check out the computer that I am assembling, it is the RC2014, which you can see at www.rc2014.co.uk. They are in no way my sponsor or anything else. I just thought it was really cool. So here we are. Wow, is that the last one? I talked that much that I got all those done. Okay. So that is the core computer. So we bring our motherboard back out, and that is the core computer. Now, what's interesting about this is at this point, after I bathe this in alcohol and scrub it and clean off all the flux, I can plug a serial cable, well, an FTDI cable, because I haven't put the Max 232 on yet. Maybe I should throw that on, actually. Anyway, at this point, you can just talk to it serially, which is great. You know, you can use the basic interpreter and you can write your own programs or even load games on it and play. But I bought this for like the programming aspect and learning things about hardware and having some fun. And so this is one of the options that you can buy with it. And what this is really simple, actually. It is a digital input-output board. So you have to interface your hardware with the real world somehow, right? So we do that in this instance with a digital I/O board. And all this really is a board with some buttons and LEDs. It is that simple, folks. So, all right, there's our ICs. And then we have 8 tactile push buttons. And then we have 8 LEDs, right? Because it's an 8-bit computer. So we're looking at 8 things at once. So we'll put our LEDs and our resistors and our buttons in there and some ICs. We'll be good to go. This is cool. So I guess I'll, should I throw this together now? Maybe. We're at a pretty good stopping place, actually, because after all, I did get the computer assembled. When am I going to power it up, you might ask? Maybe tomorrow. I might do that tomorrow. Probably tomorrow. I don't know if I could leave it alone for a couple of days. That'd be much too exciting. Wow, on this board, there's no pin 1 indication for the IC sockets. So I'm going to have to look that up and make sure that I get the orientation correct. So anyway, I am going to go ahead and end the broadcast here. I thank you all very much for joining me this evening. For those of you who are 8-bit enthusiasts, one thing that I do need to figure out, and I'm probably just going to have to use microcontrollers for this, but I need to drive a composite output. I need to find a video chip that doesn't require so much extra logic, but maybe just an all-in-one solution where I can feed it data from the Z80 and display it on a television. And I need to do this to 6 televisions at the same time. So if y'all have any thoughts on that, leave me a comment. What I'm probably going to do is use a microcontroller to generate all the video signals and hold the frame buffers and memory and all that, and then just write to that from the Z80 computer. Is it cheating? No? Who's making the rules here? I am. So anyway, I hope you enjoyed my Ask Me Anything and assembly of the Z80 Kit Computer. It just looks like a pile of stuff right now. But there will be a video on this very soon. I have been recording the assembly, so you can watch that again, albeit in a much sped up fashion with my notes instead of my ramblings. So anyway, yeah, thank you all for joining me. Questions, comments, concerns, or suggestions, hit that comments box below. Give me a thumbs up, because that's important. It actually helps. I am not a monetized channel. I have seriously been considering going that direction, because a monetized channel seems to get elevated more readily in search results and suggestions and stuff, which kind of sucks, because I'm a small guy and I like giving away my knowledge for free. At the same time, I'm kind of poor and could use a little extra cash to buy like a better webcam that has a focus feature. So there's stuff like that. But anyway, thank you all again. You know what to do. And until next time, have a good one.